Hello and welcome back to Yeyu Lab. Today we are going to build something different but quite useful, which is a real-time proactive AI agent that they don't just respond when you ask, but actually monitor something like video streams and speak up when they detect changes in the backend. So here's the thing, Google just released Gemini 3 Pro model and the numbers from its benchmark are quite impressive. Let's look at the table. You will find there is 91.9% result on GPQA Diamond for scientific knowledge, and there is 95% for the mathematics benchmark, which is quite higher. And also for the coding capability, it has a very high number that's generated from the Live Code Bench Pro, which is verifying the capability of solving coding problems. But these are not enough. The most standout feature, I think, is the visual understanding. You can see from the number, it's 31.1% on ARC AGI2, which is used for the visual reasoning puzzles. And this number is twice higher than GPT 5.1 and Sonnet 4.5. We can see how much improvement from its predecessor, Gemini 2.5 Pro. And there is another number here, 72.7% on Screen Spot Pro for screen understanding, which result is much more higher than any other models in the market currently. So these are not small improvements, right? This is a big jump on how AI models understand visual information for different cases. But there is a problem that Gemini 3 Pro doesn't have a live API model yet. So you can see from the model list, the most advanced live API model currently is still Gemini 2.5 Flash model. And in its list, you can find still the Gemini 2.5 Flash Live. So you can't use the Gemini 3 for a real-time voice conversation so far. So how do you take advantage of these vision improvements from Gemini 3 in a voice agent that can make a live conversation based on vision context? So this is where ADK comes in. This framework called Agent Development Kit is also released by Google. It lets you combine different models in one agent. For example, you can use Gemini 2.5 Flash Live model for voice interaction, but call Gemini 3 Pro separately for vision analysis during the conversation. You get the best of both, right? The natural conversation from Gemini 2.5 Live and a strong visual understanding from Gemini 3 Pro. When I developing this project with ADK, I found something even more interesting in the ADK framework called streaming tools. The background is most voice agents are reactive, which means the user speaks, the agent responds, and then waits until the next speak from the user. With streaming tools, you can build proactive agents that monitor something in the backend and actively speak up when they detect the changes. So now the agent doesn't wait to be asked. It pays attention by itself and alerts you when something happens. So today I will show you how to build these proactive agents. By the end of this video, you will have two working examples. One is the basic streaming agent that monitors the fake stock prices provided by the official demo, which explains perfectly on how this kind of real-time application developed. And with that as a base, we will have an advanced video monitoring agent that uses Gemini 3 Pro to watch your camera and alert you when things change requested by the users. For example, like when you stop looking at the screen during a focus session, the agent can proactively tell you in real-time voice. Okay, so first let me show you how this live demo looks like and give you the idea what's going on in the backend. So here is our project. We have two agents developed. One is the streaming basic agent is what the official demo provided for us. The other is video monitor agent, which is a more comprehensive real-time agent. Okay, first let's run ADK web command, which will run integrated front-end UI provided by ADK that's serving our backend agents. Okay, this is the running front end provided by ADK, integrated in its framework. So we don't have to build anything in the front end of the UI and the user experience, something like that. We just provide the agent definition in the backend. So you will see we have a streaming basic agent and video monitor agent that we provided in our project folder. So let's try the streaming basic agent to see what's going on here. Okay, now we will start the microphone communication here. Hey, can you help me update the stock price of Tesla and keep monitoring it?
Tesla's stock price is currently $199.99. I will continue to monitor it for you. The price for Tesla is now $293. The price for Tesla is now $291. The price for Tesla is still at $291.
Okay, so you see currently the voice agent can be proactive update to me with the changing of the Tesla's stock price, which is a fake price. I make a timer in the backend to pretend the changing of the stock price actually. But you see that the model can be updating very real time and proactive. Now let's see the video monitor agent to see how advanced features that it can achieve. In this case, we will activate the camera to make a live video communication. Hey, can you help me monitor the people in this image to see whether he is looking at the screen or not, and keep monitoring, okay?
Acknowledged. I am now monitoring the video stream to detect if the person is looking at the screen. I will alert you to any changes. The person in the video is currently looking directly at the screen. I will continue monitoring for any changes. The person in the video is now looking to the side, away from the screen. I will continue monitoring for further changes. The person is now looking directly at the screen with a contemplative expression, resting their chin on their hand. I'll keep watching.
Okay, you can finish your watching.
Monitoring stopped. The last observation was that the person was looking directly at the screen with a contemplative expression. Is there anything else I can help you with?
Can you help me monitor this guy to see whether he is tired or not?
I am now monitoring the video stream to detect if the person is showing signs of tiredness. I will let you know if there are any changes. The person in the video appears alert and focused, looking directly at the camera with a neutral expression. There are no obvious signs of tiredness detected so far. I will continue monitoring. The person is now holding their forehead with their hand and looking down, which is a common sign of tiredness or stress. I will continue monitoring for further changes. If you have any other questions or requests, please let me know.
Okay, so you have the better imagination than me. So I give the opportunity to you to think about what can be monitored and what can actually expose the capability of the Gemini 3 Pro, about its vision capability. Okay, so here, firstly, I will let you to know what makes the streaming tool different. The traditional agent tools are request and response functions, right? The agent calls a tool and gets a result and move on. The streaming tools are different. They are async generators that yield multiple results over time. Let me explain to you. Here, our traditional tool get weather function is defined always like this, right? So you ask what's the weather, and the model will call this get weather function as a tool, and this tool will return a stream or other type of the result immediately after its setting. And then the model will use that to make a response to the user. But now we are not return, we use the yield to make a periodic output of its, for example, here monitor stock price to output the stock price every time it change in real time, every 60 seconds. So in that way, the tool will not be returned immediately. It will into a loop, and in that loop, it will give the response for a certain period. And most important is this tool is always working as an async tool, which is running parallel with the model. So this is actually a key difference between a voice assistant and a voice companion. One waits for the ask, the other pays attention and speaks up when needed. For the ADK framework, here is the best part, that it makes the streaming tools really easy. You define an async generator function, wrap it with a function tool, and the framework handles everything else, including the WebSocket streaming, the session management, audio encoding, and the UI integration. You only need to do is define the tool, make sure the tool can yield the result, and wrap it in the function tool to set in the tools of an agent definition. So after that, you only need to run ADK web, and you will get a full UI with a text chat, voice interaction, and debugging tools. No custom front end needed. By understanding that, now when you look at the basic agent development for the monitor stock price, you can definitely read the code by yourself. The pattern is very simple. The function defined for the tool called monitor stock price, and wrap it with an async function under the async generator. And when in the function, it just go to a loop. For every 10 seconds, it will generate a random number as a price of the stock and yield that price alert to the agent, and wait a bit and repeats. Each yield becomes a proactive agent response when it's needed. And also there is a stock streaming function is helping users to stop monitoring from the voice interactive. Here in the agent definition, you can see the root agent, which can be recognized by ADK UI, is defined with the object agent with the model that Gemini 2.5 Flash native audio preview September 2025 model for the live communication. And in the description is asked to monitor the stock price in real time using the streaming tools. And there are two tools wrapped by function tool into the tools field, including the monitor stock price to receive the stock price changes, and also the stop streaming to stop that loop inside of tool. Now let's build a video monitoring agent that uses Gemini 3 Pro's vision capability to watch your camera and alert you when things change. As we have known, the GPT-3's vision capability is so impressive, so these improvements matter a lot for the real-time video monitoring. The model needs to understand the small visual changes on the image, like whether you are looking at your screen or looking away or feel tired or any other mood changes or some environment, whether the room lighting changes or other things, can always clearly detect it. By looking at the workflow chat you will be more understanding the internal logic of this agent. So here the user speaks, monitor if I'm looking at the screen, and Gemini 2.5 live model understand the intent and calls monitor video stream tool, which is a function registered to this agent. This tool will enter the continuous monitoring loop for 3 logic paths. Frame processing direction is to push the latest frame from the queue and discard the old frames. The vision analysis block powered by Gemini 3 Pro received the frames and the context and to prepare for model processing. And the structured output is the model returns the observation, which would define its output structure involving 3 fields: observation, status key, and significant change, which will help the follow-up logic to do the decision making, which has 2 decisions. One is when the significant change is true, it will yield the update to the agent that the Gemini 2.5 live model will speak the update after receiving the yield information. If the significant change is false, the entire workflow will be silent and continue the monitoring for next frame. So after the Gemini 2.5 live completed the generation, it will tell the users through the voice output that like you've looked away from the screen. Okay, that's the entire and simple workflow. So let's see our video monitor agent implementation by looking at its agent.py file to see how the agent has been defined. So firstly, we need a structured output for the change of the video detection. First, we define a pydantic model for the vision output, video analysis result, which including the observation, status key, and significant change. So basically, we need the model to make 2 decisions. One is what's happening in this frame, which defined in the observation, to help the model to respond with more detailed and accurate output from the video frame recognition. The other is status key, provide a simple state identifier like sleeping, looking, focusing, something like that. And the last one, significant change, is the conclusion of the status change based on the key to see whether this status key is representing a significant change that the user was asking to know for monitoring. Now let's see the video monitoring tool with optimization that I built in. Monitor video stream. So firstly, we put all frames from the queue and keep only the latest one. This prevents the processing stale frames if the model is slower than the camera frame rate. And second, we tell the model what's the previous status keywords. This helps it to make accurate decisions about whether something changes. And next important implementation is the structured output we have described before, to ask the model exactly follow the fields that we defined to make a clear output. Here you notice that we use the Gemini 3 Pro preview model to do this vision processing. And here the next implementation key is the smart yelling strategy. We only yelled something that we think is necessary, which means it's really changes. If nothing changed, we don't send a response to the agent to trigger the agent to make a necessary response. And here we control the rate limiting. I use the 5 seconds sleep between frames to make a balance for fast enough to catch the changes, slow enough to respect the API rate limits and token consuming. And here we also defined another function called analyze video frame, which is used for immediate result return for one-time question about what's currently visible. So the live model will determine whether the user is asking for long-term monitoring or the one-time image detection. So if it's a one-time analysis, it will go to the analysis video frame here to output only once about the result without any loop here. But if the live model thinks that the user wants to monitor the video frame for a certain long time, it will go to the monitor video stream tool to start a loop to keep processing, generation, and yielding to the model. So you can see for the final agent, it has registered with monitor video stream, analyze video frame. The two tools has been registered to handle different user case. So you can see the design pattern is very simple, but it's quite smart, right? The pattern we built here is very flexible. You can extend it by adding multiple video streams, combining with audio analysis, connecting to smart home devices or other complicated multimodal stuff to build a custom change detection. If you found it useful, I paste the link of my GitHub repository to let you find out the source code of this project. That's all for today. If you have further questions or ideas, please drop them in the comments below. Thanks for watching. I'll see you in the next video.